Welcome back students to the next module of stationary waves. In this very module, what are we going to learn? We are going to learn the concept or the MCQs which are based on the concept of vibrating string. So to move ahead with this, the very first problem is present in front of us. This problem states that whenever there is a sonometer wire which vibrates in second overtone, means they have said wire is vibrating in the second overtone. Then, if the wire is vibrating in the second overtone, there are option A, presence of 3 nodes and 3 antinodes. Option B, 4 nodes and 3 antinodes. Option C, 1 node and 2 antinode. Option D, 2 nodes and 3 antinodes. So students, this is the question in front of us, that if there is certain overtone which is there, then what is the correct in terms of node and antinode? But students, whenever I say the word second overtone, what comes to your mind? What comes to my mind that whenever there is a secondary overtone or a second overtone, it implies that it is a third harmonic for a vibrating string. So if it would have been first overtone, it would have been second harmonic. In the similar way, it is second overtone, hence it is the third harmonic. Now I know that in third harmonic, there is presence of 3 antinodes and 4 nodes. Now you must be wondering, sir, how did I get this answer from? Students, remember that whenever there is a secondary overtone, it is actually third harmonic, meaning 3 loops are formed. And whenever 3 loops are formed, it implies that there is 3 antinode. And if there are 3 antinodes, subsequently there will be presence of 4 nodes. So students, with the help of this problem, I got to know that if you know the overtone or if you know the harmonic, you can easily comment on the number of nodes and antinodes. So on the basis of this problem only, I'll give you one more example. Let me take, suppose if I say there is 7th overtone which is given to you. So based on that 7th overtone, you can say it is the 8th harmonic and there are 8 antinodes present and 9 nodes present. So students, in this case, the option was option B, that is 4 nodes and 3 antinodes. Moving ahead to the next problem. It says a sonometer wire is in unison with the tuning fork of frequency 256 Hz. When the length of the wire between the bridges is 75 cm, then only one loop is formed. That means I have been provided with the frequency, the length of the wire and the number of loop which is formed. So one loop is formed, that is the fundamental mode, when there is a length of 75 centimeter which is set up, and when there is a frequency of 256 Hz. The condition in the question says, by keeping the length and the tension as constant, the wire is made to vibrate in 2 loops. The wire can still be in resonance with the tuning fork provided the frequency of the tuning fork is. Now they are asking us the frequency of tuning fork. How do I move ahead with the solution of this problem? What is given? I have been provided with the number of loops, that is 2. The length of the string is given as 75 centimeter. Also, the original frequency is 256 Hz. The concept of solving the problem. Since 2 loops are formed, the frequency has to be the second mode, that is twice of n, and twice of n means 2 multiplied by 256. So the frequency of the 256 multiplied by 2 comes out to be 512 Hz. That means the frequency of the tuning fork has to be 512 Hz for them to stay in resonance, and that is how we will solve this problem. So the answer comes out to be option B. So students, with the help of this module, we studied the problems which are based on the concept of string, and these are the MCQs which are actually asked in examination. So students, keep solving them and stay connected. Thank you.